Right, I've been putting this one off for a little while because there's a lot to talk about and some of you buggers fly this thing, so I don't want to get it wrong. But there is a lot to talk about, and also I got accused recently of being a bit mean about Russian gear, so I'm going to say a lot of nice things about this, and I'm going to say some not so nice things because, like everything, there's always the positives and the negatives. So let's get into it. This is the MiG-21. Now, just like the MiG-15s and so on that came before it, they still stuck to that same ethos of keep it simple, make it something you can build cheaply, and try and make it vaguely peer level with what the opposition are using. But I would argue that in this instance with the 21, this is where they kind of hit the sweet spot and actually got it, for the most part, not entirely, but for the most part, they got it right. So to keep this simple and on point, I'm going to start with the pros, go through the cons, and then talk about the compromises, the bits where they kind of got an advantage by giving up something else. So let's start with the engine, which is a little bit in that category, but it's mostly a pro. What they did with this was, instead of putting a dirty great big pair of engines in it like a Phantom, in order to get this thing up to Mach 2, they put in a much smaller engine, but then they put it in a much lighter airframe, and then they gave it the ability to overcrank the engine. Now what that meant was there was like an extra pump that you could put more fuel into the reheat at the back, so that there was an emergency mode for this thing. And you couldn't stay in it for long, because if you put it into emergency mode, the thermal strain on the engine was so significant that you were absolutely wrecking the airframe. But for about 2 minutes at a time, you could whack this thing into high gear and you could achieve the kind of performance envelope of much bigger engine and more expensive jets. Also, they added a tailplane to it, but they basically put a rear tail section on it so that you could increase the stability of it, because it was a delta wing aircraft essentially with a tailplane put on the back. And that meant that it was a lot easier to control at the kind of extreme ends of its envelope. So if you were a novice pilot, you were less likely to end up ditching this into a field through inexperience. And that in itself made it another pro rather, which was it became very exportable as an aircraft, because by having it more controllable and easier to learn as a novice pilot, you could sell it to countries who didn't necessarily have the infrastructure or the money to have, expensive pilot training programs, so they could then get, good aircraft into the air and operational with crews who could use them much cheaper and much quicker than maybe some other nations were. I mean, that simplicity of design and ease of learning to use made it a very exportable aircraft. So this is probably one of the most commonly exported and made post-war aircraft. I think there's something like 20,000 of these. I'd have to actually check the numbers on that. I don't remember offhand, but it's roughly something like 20,000 of these were made, which makes it one of the most widely made jets. And one of the other features it has that makes it quite good for people who are not necessarily that great at their job, the landing gear at the front, you can actually release that from inside the cockpit. So in the event of a hydraulic failure or some other issue that causes the landing gear not to drop, you can manually release the front nose gear down in the cockpit, and then you can use the air brakes or the ventral fuel tanks, if you have them fitted. You can use them as the rear skids, if you like, and then you can land the aircraft doing minimal damage to the aircraft, which means you can get it back in the air again fairly swiftly afterwards. And speaking of getting it in the air quickly, you might notice at the back here, just behind the wing, there's a couple of attachment mounts. That's for JATO rockets. I mean, this thing could already get off the ground at a hell of a lick, but they thought, you know what, we need this thing to be like an actual rocket. So they put in a little attachment so you could put a pair of JATO rockets on the back of it and get this thing off the ground even faster. Now, it's not all sunshine and roses, so let's get to a couple of the cons. One of them, as you might can tell from the extremely slender profile it's got, is that this thing has got almost nowhere to put fuel in it. So a bit like the English Electric Lightning, the range on this was pretty limited, very limited in the early versions. And when they did resolve it by adding extra drop tanks and so on, it kind of decayed its top end, so then it didn't perform as well and it didn't have the same rate of climb and all that kind of thing. So if you had it in the standard version without the drop tanks, yes, it could climb very quickly, and yes, it could intercept fast and do all that good stuff, but its range was incredibly limited. It wasn't just a lack of fuel that was the problem, it was also a problem that the way the fuel tanks were laid out, especially again in the early versions, the aircraft would run through the fuel, and when you got down to about half fuel, you started to get into some serious problems. The first one being that as the tanks emptied, they emptied unevenly, which meant that the aircraft started to become inherently unstable, and like it would become much more difficult to fly once you were below half a tank. On top of that, if you started aggressively turning this thing, then the fuel would slosh around inside the tanks, and sometimes it would actually slosh so badly that it would cut off from the engines and the engines would stall, which then gives you another problem, which is that the fuel tank integrity is kept by putting compressed air in that's fed from the engines. And if the engine's stalled, the compressed air stops, and then you have the risk of the tanks just collapsing under the vacuum as the fuel gets used and comes out of the fuel tanks. So really not a great fuel system. You know, if you could get fuel to the engine, it worked really well, but unfortunately there was a few issues with getting the fuel from the tanks to the engine. But now when we talk about the aerodynamics, we're getting more into the compromises area of things. So it had these delta wings, and the delta wings made it pretty good. I mean, it gave it a hell of a climb rate, and it gave it that ability to be very fast. You know, it was a Mach 2 capable aircraft. But having delta wings on it meant that it also would, like, if it did do extreme maneuvers, like as soon as it got into doing turns, it would lose lots of speed in the turns. So it had that issue of, if it tried to get into maneuver dogfighting, it would lose speed constantly every time it tried to do any kind of turns. But when it did get in the fight, they did actually put a little bit of thought into looking after the guy sat in the seat. The front's got 60 centimetre deep bulletproof glass. There's like a big steel plate that sits behind the pilot. There's like a sort of strengthened bath that they sit in. So the pilot was fairly well protected. But on the other hand, it didn't have much in the way of missile lock detection, or you know, the radar wasn't particularly good. So the pilot was kind of relying on his own intuition to know when to drop chaff and flares and stuff, because he didn't have any of the kind of more advanced systems that you get on a lot of the NATO fighters at the time. This is where one of the coolest bits of design features on this aircraft, I think, is though, because not a lot of aircraft actually used this nose cone kind of nose air intake sort of configuration. And I'll get into the negatives first. The reason for that mainly is because the cone is so small, it's quite hard to put any kind of radar gear in here. So like things like the Lightning, it's got quite a compact and small radar system that gets squished into the nose cone. But this is better than the Lightning, and the reason this is better is because this nose cone is adjustable. And in the early versions, you'd have like 3 fixed positions. So if you were at one set of speeds, you'd set it to one position, or the next one, whatever. And the reason for that was because as the aircraft's travelling through the air, I mean, obviously this is a cover, the nose cone's inside here. As the aircraft's travelling through the air, once it gets to supersonic speed, you get the supersonic shockwave coming off the front. And if the nose cone's back here, the point of the nose cone's here at lower speeds, the shockwave is being diverted around the air intake. But as you go faster, that angle of the shockwave closes, and then you start getting supersonic air being blasted into the nose cone. It's not what you want. So the nose cone can come forward and then move the shockwave's origin point forward, which means that then the shockwave now passes over the nose cone again. So as the aircraft gets faster, the nose sticks out more to compensate for it. And in the later versions, and this was something I only learned quite recently, in the later versions of these, the nose cone automatically adjusts based on the speed. So the pilot doesn't even need to do anything. The aircraft will just work out how fast it's going and how big its nose needs to be to make for the most optimal airflow into the air intakes. In the event of the pilot having a bad day though, this is not really a compromised thing, but there was 2 versions of this. In the early versions, what would happen is your canopy opens that way out to that side. But if you ejected, the canopy attaches to the seat and then acts as a windshield, so that in that initial high velocity, say you're ejecting at supersonic speed, you have the canopy acting as a windshield to protect the pilot until he's going slow enough that it can detach, and then the chute can deploy and so on. But they weren't always that effective, and quite often the aircraft and the seat would come out, the thing would attach and then it wouldn't detach, and then the pilot and the seat wouldn't be able to deploy a chute, and then you'd lose the pilot. So later versions they dispensed with that, and it just blasted the canopy out the way and the ejector seat just came straight out with no windshield. But it was a different design and it didn't need it. So if it's technically inferior to the Western counterparts it was going up against, and it's maybe materialistically a little bit on the cheap side, how was it competing so well? Well, I think it comes down to a couple of things. One is the brutal attrition of warfare. The fact is, these were cheaper to maintain, cheaper to train crews for, and cheaper to get people up in the air in. So if you lost 2 of these and you shot down a Phantom, you were still technically ahead of the game in terms of attrition, because a Phantom is far more expensive and generally speaking has 2 people in it. Secondly, it's just down to pure tactics. This thing was designed to do hit and run kind of tactics, so they'd fly in rapidly into a target, hit the target and run away again before the target could respond. A little bit like the old Sabres used to do back in the Korean War. And the other thing was, they didn't have the complex electronic systems and radar and threat detection and so on board the aircraft. They used ground controllers. So they'd use ground-based controllers to tell it where to go to intercept the enemy, or they'd park them up in the holding pattern where they knew the enemy would be coming. Once the ground controllers picked them up, these things dived in, did their little hit and run thing, and away they went. So rather than having an expensive self-contained airframe, they just made it an integrated part of their overall air defense strategy. In the end, it's hard to argue that these are not a success story, because they made loads of them, lots of people operate them, they're simple, and they fitted exactly into the niche they were designed for. And even now, when they're pretty clearly an outdated airframe compared to a lot of other stuff out there, they're still going. There's still people operating them, and there's still people making aftermarket, like accessory packs, if you like, for them. There are plenty of companies out there who make advanced avionics for these and make advanced radar and detection systems and weapons packages. So even now, it's still a pretty capable and formidable aircraft. If you've enjoyed the video today, please consider a like and subscribe to support the channel, and feel free to watch one of the 2 videos suggested in these boxes.